Okay, welcome everybody. It is time to begin, and it is 3 o'clock in the Eastern Time Zone. I'm just delighted to have all of you join us today. We are in the CapTex Talk Plugged In series. These are webinars that were designed originally for high school and community college transfer students, but really they are of general interest, and almost anyone interested in the fields that Capital works in the STEM fields will have found these to be of great interest. And I think today's session is no exception. It'll be a great session looking at autonomous systems. I look forward to the time that we're going to spend together the next hour. As I mentioned, this is in the Plugged In series, and this is the 8th and final webinar in that series. Today, November 13th, and by the way, a happy Friday the 13th to you. We'll be talking about the future of unmanned autonomous systems, but we've had excellent sessions dealing with the life of a student, with projects that students have undertaken, how to build a robotics car, and last week even the basic physics behind why it appears that the sky is blue. This has been a great series, and just to let you know that all of these series have been recorded and are available on demand, and this one will be as well. Now, today the session will be the future of unmanned and autonomous systems presented by Anh Ho, and I'll introduce our presenter in just a little bit. I wanted to give a little bit of agenda here and talk briefly about Capital Technology University in case we have those who aren't that familiar with it. And in addition to that, after we go through that, we will have a few session pointers, housekeeping, if you will. Then I'll introduce the speaker and the presentation will occur. We have a group today that if you have questions, we'll take the questions at one of two stages. During the presentation, we will be monitoring the questions and answer questions during the presentation. And we'll definitely allot time at the end of the presentation for additional questions. We'll try to get as many of these questions answered as we possibly can. And then at the end, we will cover how to get a copy of the recording and the slides. Just to let you know, the session should last just 60 minutes or less. 3 slides dealing with Capital, and I know from looking over the audience members that several of you are extremely familiar with the organization, but I think it's helpful in case you're not to cover the highlights of our organization. Capital is a nonprofit, private accredited university physically based in Laurel, Maryland, but with an impact around the world. And even our audience today represents that worldwide impact. We are fully accredited. We're accredited by the Middle States Commission on Higher Education. It's regional accreditation, which is the highest level of accreditation available to any university in the United States. And we're also authorized by the state we live in Maryland, by the Maryland Higher Education Commission to confer degrees all the way from the associates to the master's, bachelor's and master's, right up to the doctoral level. And we offer 2 doctoral degrees, a Doctor of Science in cybersecurity and in one other field, and the multiple numbers of PhD degrees. We're an award-winning and STEM-focused university. We were the winner of the prestigious 2020 SC Media Award for the best cybersecurity higher education program in the United States. Quite an honor. And we're also the only independent college in Maryland that's dedicated to the STEM arts, to engineering, computer science, information technology, and the management of technology through business. I wanted to talk end our section on Capital talking about something that very few people are aware of, but is a tremendous guarantee to our students at the bachelor's level. Our guarantee is if you graduate with a Capital graduate degree, that you'll find a position in your field within 90 days of graduation. And if you don't, if it takes you longer than 90 days and you wish to get more education while you wait for your job to open up, we'll provide up to 36 credits of university education, tuition free, to assist you. We're so convinced that you will have a job within 3 months of graduation that we very rarely have had to offer this to anyone. And why do we say that? Because according to a Georgetown University study, Capital Technology University is ranked in the top 3% of 4,500 colleges and universities in the United States for the lifetime return on investment on money invested into a college education. Top 3%, actually it's the top 2.6% to be precise, of all of the colleges and universities in the United States. The return on investment is tremendous, and we know that people who come through our programs and get degrees will end up with a well-paying job in their profession. Now, changing gears and moving away from capital, let's just talk about some session pointers. At any time, you can post a question in the text chat, and we will be monitoring it. And depending on the presenter's preference, he will either answer the question right on the spot, or we will collect the questions and answer them all at the end, but we will answer them. We're not activating your microphones or your webcams for this session today, so the way we'd like you to communicate with us is through the text chat. We will provide the slides and a link to the recording to all registrants, both those who attend the live session and everybody else who registered who plan to watch it on demand. And we'll make sure you get that. We'll talk just a little bit more about that at the very end of the presentation. As I mentioned earlier, the presentation should last a little bit less than 60 minutes. Now, just about time for our presentation. Let me talk briefly about our presenter, Anh Ho. We're very pleased to have him join us today. I'm going to read this so I can make sure I cover it right. Anh Ho is a Capital Technology University graduate where he majored in computer science for both his bachelor's and master's degrees. He was software lead for Project Hermes, a NASA suborbital RockSat-X program to launch different experimental payloads into near space. As an undergrad student at Capital, he interned at NASA's Goddard Space Flight Center in the Space Operations Institute program, working on several projects, including the Tropical Rainfall Measuring Mission, the Terra satellite, and the Magnetospheric Multiscale Mission. After graduation, he joined Textron Systems, Unmanned Systems as an engineer, where he worked on distributed cloud processing for manned and unmanned remote sensing products and deep learning with neural networks. Anh was the first air vehicle operator, AVO, at Textron to successfully execute an autonomous mission with an experimental unmanned aircraft. He is currently a systems engineer and ops lead for the Department of Defense. It is with great pleasure that I present our presenter, Anh Ho, and I give control to him.
All right, thank you very much, Bill. And welcome, everyone. Welcome to our final CapTech Talks plugged in. I'm glad everyone's here, and I hope that today's presentation will be useful for you in helping you choosing your future career path or learn more about the subject of unmanned and autonomous system. Next slide here. Bill, I have a little, that is. I got it. All right, so for today's sessions, we'll be talking about UAS and what exactly UAS and a little bit history of UAS and what others have you been used this system in the past and why we're using it, and some of the current UAS applications. We're gonna take a touch base on what the future look like for UAS. And at the end of the sessions, I will show you some tips and tricks on how to build your own UAS system. So what exactly is UAS? So in these sessions, we're gonna call UAS as Unmanned and Autonomous System. You might have seen this acronym somewhere before, and it might stand for Unmanned Aerial System or Unmanned Aircraft System. But for this specific system, we'll be referring it to Unmanned and Autonomous System. So UAS is a system that contains no persons or pilot on board. It can be teleoperated or remote controlled, capable of carrying out a prescribed task or a partial of the prescribed task automatically with minimal human interventions. And in, UAS presence in everywhere. It's in all the most four domains, which is water. You got unmanned water vehicles, or unmanned surface vehicles, ground, which is unmanned ground vehicles, and air, unmanned aerial vehicles, and space as unmanned spacecraft. So most people refer to this as drones. However, like when to talk to my parents and when I'm talking about drones, they will be thinking of the little toy that you bought from Amazon and you just fly around the neighbor to annoy the neighbor or something like that, or just these little commercial off-the-shelf product that you use to flying it around. But drones means a lot more. It's like I said, it's present in all sort of domains here. So here's some of the example of the unmanned aerial vehicles. That's ranging from the little tiny toy that you see there, which is the little, probably like $10, little drones that you can fly around with minimal assist. As well, it's go up to a different size here. So there are actually 5 group of unmanned aerial vehicles ranging from group 1 to group 5. And it's basically just define how large the drones is and what capability it has. As you can see on the left upper hand side here, you got the Global Hawk, which is a US Air Force drones, and it's really big. And the picture in the middle is me with one of the Textron product that we've been working on. It's a VTOL platform vehicles that be able to do vector thrust control for vertical fly as well as fixed wing fly. And there's also several other product that's being used in the military, and you're probably familiar with the DJI Mavic Pro here. That's everyone can get their hands on. So all of these drones are considered as unmanned aerial vehicles because it flies. And a little bit about unmanned ground vehicles. Unmanned ground vehicles just mean that it just operate on the ground. And there are several different type of them, ranging from like again, the remote control toy. That is technically an unmanned ground vehicles because it's a smaller car. But there are other areas that unmanned ground vehicles being used. For example, for the firefighter, that's the How and How Technologies, which is one of the the Textron company that they just acquired. They're building tank, unmanned electric tank, and some of the vehicle is using the fighter fighting as well. And on the bottom right, you can see that's a little military unmanned vehicles that's used to carry different components on board. And go to the next domain, we have unmanned marine vehicles. Basically deal with everything water and underwater. You can see that there are different products. You do have like unmanned boat that you can buy as well. Those are like little toys, but the scaling up and adding more sensors and more stuff to it, and it turned into a military or scientific research vehicles that capable of going to the depth of underwater or on the surface of the water, and the purpose of it is it having like endless applications in this area, and we will be talking a little bit about that later today. And next is unmanned space vehicles. As you can see here, there's a multiple vehicles here that's present in space. The best one that you can take a look at is the Curiosity that's currently being controlled on Mars and doing some of its autonomous missions on Mars. On another planet. Technically, it's a ground vehicle, but it's actually being launched into space and communicate through another planet. So I kind of put it to the side here for space vehicles. But there's this one that's on the right. That's the Tesla Roadster. That's a SpaceX launch into space. Technically, that is unmanned space vehicles. It might not be autonomous, but it has some sort of injection orbit in there that allow us to go into a certain orbit. And Sputnik was technically the first unmanned space vehicles out there. And then there's an upper left one is just one of the Boeing space aircraft, or one of the spacecraft that they are using for military purposes. So let's touch base a little bit on the UAS history. So In the 350 BC to 400, the first known UAS was a steam pigeons with a hand launch capability. So it's just a steam pigeon that they hand launch it, and it's just pushing out a bunch of steam to provide propulsions, and it allow it to go to fly for only a couple hundred meters. But that was pretty impressive back then, and that was the first UAS, considered as the first UAS. And in 1849, Austria attacked Venice in Italy with unmanned balloons loaded with explosive. So at this time, they start using unmanned for other applications, in this case, military applications. And in 1898, Tesla invented the world's first remote control weapons. And this opened to many other applications and expanding the human knowledge of radio wave, and is allowed for remote control vehicles, allowed to get telemetry and command, and building a much longer range aircraft. And in World War I and World War II, that they use unmanned vehicles using for ISR. And ISR is intelligence, surveillance, and reconnaissance. We'll talk a little bit more about it in later slides. And in 1936, Alan Turing invented the Turing machines, which lead to the inventions of digital computer. This allows for more computations. What does it need to be computed? Algorithm and procedures. And this opened up to a whole new era of computing power, allow it to go into making the system more autonomous, because now you have some sort of decision-making computer. And in 1995, the space race started with the launch of Sputnik, which is the Russian first artificial satellite. It doesn't do much. It just orbit and then crash and then just pump out a radio signal, and then just be able to like beep, beep. But that's open to the space race and starting the satellite launches and development of different aircraft and different satellites, and just opening up a whole new world of space, unmanned space vehicles. And toward to the modern day, so now we have all sorts of things that's popping up in the last decade. There's a lot of different unmanned system or unmanned aerial vehicle that using in military applications, civil applications, and even in the commercial space as well. And also you can see that there's many companies that already start working on unmanned autonomous system out there, like Google Car, Tesla, and Textron, and Bell Helicopter is making like some sort of design for, they call the Bell Nexus, and it's like an unmanned, not unmanned, but like autonomous system for taxiing people around. And there's many others. Modern day technology is now being developed, such as the latest is 5G technologies. It's just opened a new world for UAS. So why do we use UAS? So UAS is being used because we wanted to do the dull, dirty, and dangerous job. So what does it mean to be dull? So in the factory, you have to like close the boxes. You have to solder this, solder that, and to assemble a car, for example. Those jobs are very dull because it's repeated. It's just repeated, doing the same thing over and over again. So why not using an unmanned and autonomous system for that? So it can do it precisely because the task is simpler, and it can assemble. And you can see now with the factory, they actually already been using this for decades to assemble cars, to assemble different and manufacture different items out there, even building rockets to do all the dull jobs. It's just a repeated job and boring job. Robot can do it because they're not bored. They can just doing the stuff that they're programmed to do over and over again. And talking about a dirty job, they have robots that go into firefighting, for example, going to a dirty area to clean the tank or clean the septic tank, or taking out like doing trash and doing vacuum. They can do all the dirty job for you, and also do like clean oil spill, as well as many other applications that allow like it's dirty for a human to do. And the last thing is dangerous, and this is the really big thing. dangerous job, especially in the military. You want to you send out a robot to scan the area to know what's dangerous hidden, like bombs, landmines, that kind of thing. And even for firefighting, so people have been using drones to deploy into a forest fire to know like where we should focus on the fighting effort to take care of these fires. And also talking about going to space for that vehicles for the curiosity to be on Mars. Mars atmosphere is dangerous. We don't know a lot of things about Mars. So we send a robot there to study all of these things. And before Curiosity, NASA already be sending probably more than 10 robots out there to study Mars and atmosphere. And even going to the moon, that China just landed one of their drones in there, up there. So doing the dangerous jobs here. And it's another domain is water. There are submarines that going very deep. And as you know, that when you go deeper into the water, it's gonna have like a lot of dangerous things that come up, like the pressure. So rather have a building a manned system to go out there, an unmanned system will be safer to do these explorations. And UAS is also very cost effective compared to manned products, because for manned product, you have to be designed to protect the person inside it as well. But for UAS, you don't need all of that. For example, a little drone that when you crash it, there will be no damage, minimal damage to a person unless it's crashed into somebody. And the component that make up an unmanned autonomous system is also simpler and cheaper as well. And it's also smaller. UAS is easier to train with minimal experience required. So that's why they have those DJI drones out there that allow you to fly with minimal experience. It's just like a small guide that you need to read, and a small video, a very short video that you have to go through in order to fly these unmanned aircraft, because the capabilities of the system now is very impressive. It be able to stay in the air and be able to assist you with some of its autonomous functions. That's allow it to go into flying an aircraft or to a remote control car with ease and with no training or with no extensive training needed. And UAS is also very efficient. In this case, we're talking about Mars robot that's being exploring without human intervention. They just need to watch it, or to farming vehicles that allow it to do to taking care of the crop at a long period of time without the needing for break. And UAS also provide a benefit that are not achievable by manned vehicles. And this is where we talk about the dirty and the dangerous again. So with manned vehicle, so let's assume you have a forest fire. It's going to be extremely dangerous to fly a manned aircraft out there to take photos, or into a storm to take some measurement of the storm. It's a dangerous work. So why not send a UAS to do that? And these are the stuff that's not achievable by manned vehicles. And UAS will also produce minimal risk to personnel or properties, because the size of it, unless we're talking about like, large military, specific military aircraft, that's something that can get very large. But for a smaller unmanned system, it's have minimal risk to personnel because the size of it and what it can carry. UAS also have very low operational footprint. You can launch a DJI drones out of your hands, and you don't need a runway for it. It can be hand launched, and also it doesn't require a lot of infrastructure to operate a UAS. All right, let's talk about UAS military applications here. ISR, intelligence, surveillance, and reconnaissance. So this basically means watching and to surveil an area, to watching it. So you can see the Hornet on the right here. It's very tiny. It can fit it's about 6 to 7 inches long. And this thing is so capable because it carries so many sensors, complex. This is quite complex system, but they try to make it very simple for people to use, because everything on board, it can make this thing fly autonomously. And it has a camera, it has multiple sensors in front of it, be able to see an infrared band as well as EO band, which is your video cameras. Imagine sending this out and to monitor a certain situations, or when it's in the war fighting to aid in the fighting of the wars, for example, and many other applications where larger aircraft is incapable of doing such tasks. And UAS have a military applications for SIGINT, commons, and humans. So SIGINT is signal intelligence. So a drone standing out there is able to collect a lot of data over the air, a lot of radio wave, because everything is communicated to radio wave RF, radio frequency. That's cell phone communications and all that all that's signal intelligence. An aircraft can be able to go into the enemy territory, high in the air, or on the ground, sneaking in and collecting those data. And communication intelligence, what commons means, is to surveillance the communications of the enemies, as well as relate signal to another place. And human intelligence, this is where they're taking photos. Human intelligence usually deal with spies and people in interrogating persons, but human in the U.S. in UAS application would be taking photos of people, taking photo of an area, and taking, or you can call it geospatial intelligence. UAS is also used for communication relay. So if you send 2 aircraft up in the air and across the mountains, and these can be used for communication to the troop by beaming different signals, and it's a relay over the mountains, for example. And UAS also used for tactical airlift. Tactical airlift here means deliver different component to the troop, or just deliver supply or like med kits, for example. That's also can be used by UAS technologies. Sentinel, sentry guard, means to just to look at an area and make sure that there is no dangers is coming toward a troop or toward the U.S. base. And the big thing here is the convoy and logistics support. So when troop is moving from one place to another, that's a very dangerous area. There could be landmine, there could be hidden danger that cannot be seen by human eyes. So they can send out a robot to sweep the land and to sweep to see if there any landmine out there, or send a drone up on the sky and see further ahead to see if there any danger, and to provide convoy and logistics support. And chemical detections is a big thing as well. So with chemical detections, they're sending a drone up there with sensors that's capable of seeing through different chemical or to the atmospheric and measure atmospheric conditions. That's allowed to see different kind of chemicals in the air in case of a chemical attack or something. They can determine where it's coming from, what is it, and how to avoid it. And the last thing most of you guys know, weapon deployment or airstrike. The U.S. military has been using drones for a long time for this specific applications. As we've seen the Global Hawk earlier, it's capable of carry different missile, especially the Hellfire missile. And this is one of the applications that the U.S. military is used for, is to deploy weapons. Now we're moving on to the civil applications. In civil application, we have the law enforcement support. So provide situational awareness similar to military application, but in this case in the U.S. Soil. Provide the situational awareness, coastline and border patrol. As you can see, one of the Predator pictures right here is the U.S. Border Custom and Border Patrol. So instead of sending a lot of people to watch all these area down in Mexico or near a border, they can just need to send out drones, and it's just flying back and forth and they can just monitor it remotely. And it can be used for wildlife conservation and monitoring as well. So there are poachers out there, and they can use, if the law enforcement can use aerial photography to find these people, because it's carry IR camera, it can see through a certain object and be able to detect heat of the persons, so it can track down persons and the bad guys, as well as to see the wildlife, to study the wildlife, for example. And another civil application is disaster response and management. We talked about the dull, dirty, and dangerous before, so this is where it's coming in. Disaster response, search and rescue is really big. The Civil Air Patrol, which I'm part of, is also using the unmanned aircraft system for search and rescue because it's quick and quickly deployable, and it provides aerial photography for searching in a wider area. And it can also be used for damage assessments. So especially after a hurricane or some sort of weather phenomena, then it can be used for damage assessment. There are companies out there that contract with Textron to provide ortho reference image for a farm that being destroyed by frost in Australia, for example. And these are really large farm, and it's using for and after the frost, the farm is being like destroyed, and they don't know how much damage is being done. And for farming in this large scale, they have insurance, and the insurance and company saying that they need to provide proof that the crop is damaged. So all we need to do is just fly an aircraft up there and taking photos in the aerial photo in a large, wider area, and that can be used for damage assessment. And firefighting as well, like detecting hotspot and where need to focus the firefighting effort. And meteorologies, satellites. These satellites or unmanned aircraft that fly into the storm to measure and to do some scientific study, to predict the weather patterns and to do change detections. So you can have, this is mostly using on the satellite and aerial applications, where a satellite is taking photos of an area, and then another photo in 30 years, and then another photo in, not 30 years, in 30 days, 60 days, 90 days, in that, and combine all of the image, they can do what is called change detections, like what being changed and how, like study soil conservation, for example, and like what happened when a tree is falling and like being cut from the forest, and they can monitor that area, and they, with the image over time, they can do a change detections and assess and study that kind of thing. And most also scientific study is being used. I study the weather pattern, fly into the storm, understand the storm, and in order to avoid it and to predict it. And now we have commercial applications. In the commercial applications are endless. Infrastructure inspection. So if you have a very large, take a look, for example, on the earthquake in 2012 that hit that we can feel from here, and they have like some crack on the Washington monuments, and to get up there is kind of tough. They can either have a helicopter go up there, but they can also use drone. Drone can just fly up there and zooming in and can see the damage so easily. Another really good example for infrastructure inspections is railroads. And we have a really, really long railroad track, even one from Chicago to Washington State to Seattle. And that's a lot of railroad to inspect if you do it by hand or by a person. The easiest way to do this is just flying a drone, just taking all of these photos, and you just mosaic them together, ortho mosaic them together, and you can have a larger photo, and you can zoom in to see the damage. With aerial photography in commercial space, these camera is very high resolutions. We have camera that can even do 3 centimeters GSD, or GSD stand for ground sampling distance. That means that every single pixels on that pictures is equal to 3 centimeter in real life. So you can imagine, say, how much you can see with that when you would do railroad inspections. And in agriculture as well, automated farming, like those, they have vehicles out there that go around cutting crops or pick berries, for example. Those are autonomous farming as well. And aerial photography in the last few, and filming in the last few years has become huge because of DJI and all of the drone technology. The fly came out there that's allowed to make this possible. A lot of YouTube video up there that's allow you to do aerial photography with just drones, especially the DJI. They're fairly affordable, but can create like a stunning image and stunning videos. It's pretty amazing. Survey and mapping. You can see the picture on the right here. Survey and mapping is being used to detect, like they can map out an area, and this is being used by Google the most. In the past, they use an airplane that's flying around the world, with a giant camera pointing down. In the past, you don't really get a good image out of Google Earth, but now you can get even in 3D buildings, and these was done using survey and mapping capability of UAS system. You can program a UAV to go up there and flying at the mode lawn pattern, go back and forth, and scanning this area, and using technology now with the higher computing power, you can process the image and turn them into, and then basically stitch them together, but geo-reference, that means that the image is fit perfectly where you overlay it on the map. And this allows you to have higher quality photos. You can even get the 3D building out of Google Map. That is being done by aerial photography. With multiple image and multiple angle are sweeping back and forth and overlaid. With software, you can actually create a 3D object out of it. And we talked about damage assessment before, similar to in other space, is to do damage assessments in a larger scale. And real estate. So with real estate is now when you go shop for a house, especially in this pandemic, you can look online and you can actually see the 3D model of the house that you're about to buy. And that is really cool. You can just, there's also like drone view and aerial view allows you to view outside of the house. And that is how it's being used in real estate. They're flying a drone around to take photos. And for transportation as well, this is where autonomous car coming in. Tesla is working on autonomous. They just released their fully autonomous software, although it's limited to a certain customer. Darn it, I didn't get it. I didn't get the software update, but it's gonna be really impressive. Although it's not a unmanned system, but it's fit in the category of autonomous system. It's allowed with a minimal human effort. With nowadays, Tesla is capable of going on ramp, off ramp, changing lane, detecting traffic light, cones, as well as other obstacles in the area. And and they are planning on going fully autonomous in the next few years. So that's pretty impressive with the what they can do with the autonomous system. And let's talk a bit about the UAS future. So now we're replacing people with robots, and it's gonna take away your jobs. I don't think so. So with the autonomous system, with all of these systems, you still need somebody to build it. You still need somebody to watch it. It's not fully 100% autonomous just yet, but it will in the future. And one is that even if it become autonomous, you still need some sort of people to watch it, and you need more engineer. You need more people with different disciplines. Even in the cybersecurity area, you need people to secure the link, the control link, and the network that your UAS operate on. So I think that UAS in the future will create a lot more jobs than is taken away. It can replace people that doing the dull job, like the repeated job, but now it's opened a whole new world for new engineer, for new people and working at like several disciplines in the unmanned industry. I think UAS is going to be the next big thing in the next couple of years. In the future, you're gonna see driverless car. Although there will be laws and regulations that you have to deal with, but driverless car in the future is 100% possible. And with the new 5G technologies, it's gonna open a whole new world for communications and gonna be a lot better for these cars to communicate each other or to communicate with control, for example. And you will see automated factories. And again, you need somebody to build these things and to build it and to improve it as well and to maintenance as well. So we're actually creating more jobs and even save lives. You have like robots, you have robots that's fighting a war and try to resolve conflict. And so you don't see people killing people anymore. Maybe there will be just robots fighting each other and who got the better technology win, I guess. But there will be, this will be saving lives, like for firefighting, for for like flood management or for weather, or predicting weather patterns, and to have the early emergency alert, that kind of thing. All these things that we already been doing, but it will be even more things happening in the future that allows to save people's lives. And space explorations. I think next year's another rover gonna land. I think it's maybe early next year. Another rover will land on Mars, and they're also going to send a helicopter on Mars. And space exploration is endless. Land vehicles to do mining on an asteroid, for example. So these applications are endless. And again, with the 5G technology, it's going to allow us for faster decision making with autonomous robots. It now is allowing so when you drive a car, most of the cars nowadays come with what I call adaptive cruise controls and emergency braking. So the car is making a certain decisions in there that is faster than humans. It'd be able to see the objects and process that information a lot faster than humans. It will brake the car if it's about to hit an object. And this will also come back to the person. It will save lives, and it's allow for faster decision making. Imagine an autonomous system will do all the scanning and everything for you, and all you need to do is to use that information to make a decisions. And artificial intelligence and deep learning with the new processing power and a new processor capability and computational power, artificial intelligence is about to become reality. Whereas so talking a little bit about deep learning just basically you feed it a bunch of data and it will correlate all of the data and study it and making weight or connections. It's like building a human brain. It actually have artificial neurons, and it's allow it to study based on the data they're giving it. For example, you give it a massive set of data, like 100 photo of cats, for example. The system will be able to learn what a cat is and be able to do object detections, object recognitions, and with this technology, it will improve the UAS technology in the system in general with the artificial intelligence in the future. Although there's maybe some people saying, what happened if the Skynet happened? And you can see there's a picture of Skynet earlier. We're not there yet. We still have a lot of work to do. All right, let's talk a little bit on building your own UAS. So what you see on screen right there is a Pixhawk system. They are basically just plug and play system. Pixhawk system is an autopilot. It allows you to do to fly your aircraft and to do flight planning, to do even do object recognition with the extra compute power that you can attach to it. It's a flight system. All you need to do is buy all these components, put it on a shelf or vehicles, and it will turn into a UAS. The software is totally open source, and the ground control station is also open source, and it's allow you to do a lot of different things. So for all of the UAS, they all have very similar components. The first component you need is the vehicle itself. What you're gonna build? Is it gonna be a ground vehicle, underwater vehicles, or gonna aerial vehicles? Space vehicle might be a little bit far-fetched here because the space is complicated. When you try to get up there, the spider environment doesn't like it. It doesn't like these type of systems. So let's stay within the Earth atmosphere for the Pixhawk system. I don't think it's capable of doing space because, you know, with the deal with the vacuum of space and the temperature, there will be a lot of like reinforcement that you need to do in order to fly in space. But for the Pixhawk system, it's perfect for ground and underwater vehicle. You see it really well. Ground vehicle and air vehicle is what best for the Pixhawk system. And you need the second part is the communication and data link. So how are you going to communicate to your aircraft? And they already have the commercial off-the-shelf components out there that allow you to seize these to control your aircraft. You can just plug into your computer and it will connect to your vehicle automatically. And you need a payload or sensors. In this case, a payload can be a camera. A camera is considered as the payload. It's allow you to take data, and the take data is in photos, And sensors, Pixels already have a bunch of different sensor components in there. And so you don't really need to think much about sensors in this case. But if you would like to add more like ranging or radar on it, feel free. And command and control. Command and control can be done via a software called QRail Control. QRail Control is very capable of flying any Mavling robot. And Mavling is just a Pixhawk protocol or Ardu pilot protocol on how the aircraft is communicate with your controllers. And launch and recovery elements is also important. How do you gonna launch it? You're gonna put like hand launch it with fixed wing aircraft, or it's gonna be a VTOL, which means like a quadcopter, it's gonna just go straight up. So need to think about that components. And power, battery, how are you gonna power it? With batteries, it's highly recommend to go with a LiPo, although LiPo is very dangerous to handle, but if you do it correctly, it gives you a lot of power to consider its size. With the LiPo batteries, you can have a longer flight times, and as well as it's very durable as well. But the only disadvantage of LiPo battery is that it doesn't work well with really cold weather, because because of the makeup, the chemistry in there is not as efficient. So if you take a look at the diagram on the right, that is everything that you need to build your own drones. And I would say it will cost you about $150 to $200 to build your own drones that are way more capable than the DJI drones out there. And you can practice some of the UAS technologies out there. They like do flight planning, do like aerial inspection. You can go have a flight plans and you just upload it, and you can see the aircraft just go out there and just doing itself. It's very easy to tune this aircraft, and tuning means to deal with the PID, the control loop, to make sure the aircraft is stable. But the Pixhawk system is capable of doing autonomous job. And that is pretty much it for my presentations. I do have a backup slide here that I want to talk about. So there are five stages of automations. So the driver only, that means you need a person to take control and function of everything at all times. And you have some assisted driving. This is where we are right now. With all the car out there that's capable of auto braking or keep a distance or adaptive cruise control. So we are at the assisted driving. I think Tesla is a number 3 or number 4 on the list here, because their vehicles is capable of cruising automatically, lane changing, and be able to slow down, speed up. When I'm in my Tesla, I don't need to do anything. I punch in my address and hit go. It drive me to work, and it going on the RAM automatically changing lane. And when I get to work, and it's just telling me some of the autopilot function might not be available because now I'm getting into a smaller road, but it's capable of driving me to work automatically. It's kind of cool. And what we are trying to get is to number 4 and 5. This is where everything become autonomous. No human read it, and no human need it. So you can read a book in the car when the car is driving yourself to work. And Tesla is really, like I said, they just released the software that's allowed for fully autonomous driving. So that's pretty cool. So this concludes my seminar or my presentation for today. Feel free to ask me any questions. I'll be here to try to answer them.
That's great. I've enjoyed that. This is a tremendous thing, and I have all kinds of questions myself, but I want to open the floor first to our attendees to see if anyone has a question. As I mentioned before, we'll handle those via the text chat. So if you have a question, go ahead and pose it now. While you're typing, I'm going to ask a question or two. You mentioned that there's a way for people to pick berries in a farming operation, that there would be autonomous vehicles picking berries. They would do it on the ground. For example, if they had blueberry bushes or something, that they would move along and be able to identify what was a ripe berry and what was not a ripe berry. And so these are that's actually existing right now.
Yeah, so the way that they work is a vibrator. So they have like it's attached to the bush, and it's just catching all the ripe berry that falling down. The unripe one will not falling down. but although some of them will be falling down. So that will be a sorting, autonomous sorting out there, sorting by using camera to detect those unripened berries, and then so just blast it out with an air. But automated farming is already out there, even for like harvesting crops. That's possible, and it's also for picking cherries. That's being done autonomously as well. But back to your question, you're asking if they can be able to pick the berries individually. We're not there yet. There's our technology, but to build it, it will take time. But the way that it works is to shake the bush, and all the ripened berries will falling down. It will catch it.
All right, thank you. The reason I asked that was because my wife, when she was a child, back before they had a lot of child labor laws, that was her summer job, was to pick blueberries, and that's how she paid for all of her school clothes. So she'll be interested to know that she could have been replaced by a machine. The other question, I'm looking here, I don't see any questions coming in from our attendees just yet, so you also mentioned that you were involved with the Civil Air Patrol. Now, is that in terms of autonomous systems, or are you also a pilot?
Yes, I do have a Part 107 pilot's license. So my position with the Civil Air Patrol is I'm the chief of Maryland Wings UAS Operations. So I handle all of the Civil Air Patrol when it comes to aerial imaging or UAS system, like small unmanned aircraft system.
Wow. Well, that's neat. Thank you for your service. I appreciate that. I'm sure the citizens of Maryland appreciate it. I wanted to segue here while you answered my question about Skynet, and I think that's an automatic question that everybody asks. It has to do. Okay, now I wanted to move ahead just quickly. Well, I'm still opening the floor for questions if they're out there, but one of the things you mentioned was machine learning. And on November 17th, which is just a few days from now, next Tuesday, Dr. Robert Steele, one of our faculty members at Capitol, will actually be presenting a webinar on emergent technology dealing with machine learning and artificial intelligence. I would want to make sure that everybody is aware of that, since it's a beautiful segue into what you were just talking about. There's another webinar on November 24th on construction safety advancements with Dr. Linda Martin. I'd encourage you to check both of those. And while I'm giving the promotions for other webinars, let me mention these. On November 20th, which is a Tuesday in several weeks, that's the Tuesday before Thanksgiving, Dr. Dennis Beatty, one of our faculty members, will present a 360-degree approach to executing a vulnerability management program. And then on Tuesday, December 4th, our final webinar of the fall will be with our president, Dr. Brad Sims, who will talk about a brand new degree we're rolling out with Capitol called Professional Trades Administration. I wanted to just make sure that everybody was aware of those. I'm looking at the questions. I see no questions, so I'm going to ask one more, and then we're going to make sure we end on time. A couple years ago now, probably 18 months ago, there was a lawsuit concerning Tesla because a man who was not paying attention to his car driving, the car mistook the side of a truck for a road, and he crashed right into the truck. That was some time ago. I mean, in technological terms, that was a lifetime ago. But I think that is one of the fears that people have with autonomous driving and autonomous flying, is that the machine that is making these decisions will incorrectly interpret the data and cause someone to lose their life. My observation here, and then I'd like you to comment on it, is that actually many more accidents are caused by people on their cell phones and or who are fiddling with the radio or whatever they're doing than probably would ever be caused by Tesla, because I think by the automated systems. Would that be a fair comment, that it's probably you're safer in a Tesla than you would be driving a Toyota Corolla down the street and playing with your cell phone or smoking a cigarette or whatever people do?
So you driving a Tesla, and I think this is, it's people need to understand the limit of the technologies. You are driving a car, you are still being in charge of it. I don't think anyone will going to win that lawsuit, because when you turn on your Tesla, there's a right there right away that you need to pay attention. You cannot rely on the technologies. There's a reason why with Tesla, they are using cameras more than any others manufacturer out there. My car have 8 cameras surrounding it and 8 ultrasonic sensors. So that technology is based on a deep learning and neural networking. So when it's first released, it's not capable, it doesn't have enough data for it to process. I'm not speaking on behalf of Tesla here, but I understand how it works behind, because this is my area. I just love autonomous car and that kind of things. But when you drive a Tesla, it doesn't give you the right to be just take your hand off the wheel and just let the machine doing it. It's an assisted feature, or how they're advertising it. Although it's a full self-driving, and they are selling the features, but it's not yet available, or not yet 100% perfect. So when you drive a Tesla, it will be a lot safer than, but you need to put your hands on the wheel and get ready to take over at moment notice, because the Tesla technologies is based on learning. The machine is keep learning, and your Tesla communicate with the Tesla cloud, and is allowing for all of these processing, all the new thing that it learns. So one of the really good example is the Tesla keep mistaken at taking the 695 exit number 18, because 18A and 18B, they are very close to each other. So when I punch my address for it to drive me home, it always takes the wrong exit. But I took control over it every time. Now the car actually learning, and it's the right exit this time. The car is constantly, it's a learning system. So I wouldn't trust it 100% of the time. It will do its job. It's doing well. It's doing a lot better than many other car manufacturers out there. But there are limitations to the technologies, and people need to understand it. It's not yet 100% autonomous. As you can see on the scale from 1 to 5, right now the law is saying that is number 2. Although Tesla actually in the 3 or 2 or the 4 with the latest software updates, but they are still number 2 with minimal assistance from the software. So you need to pay attention to the road.
Okay, well, thank you very much. And I see that our time is drawing to conclusion, so we're going to go ahead and wrap this up. I always promised the audience that we will get this done in 60 minutes. This does conclude the webinar. Those of you that are watching it live now, watch for a follow-up email, which will actually be sent to all registrants, including those who were not able to join us for the live session. It'll include a link to the recording, a copy of the slides, and information about upcoming webinars. So be watching for that in the next 24 hours. I'd like to thank you again for a tremendous time. I've really enjoyed this, and I'm sure our audience is as well. And so we will wrap this up at this point. Thank you very much, everyone, for joining us for this, and for those who will be watching this on demand. If you do have any questions, feel free to fire them back to me, and I'll make sure that On gets them and answers them. Thank you again, and with this, we will be officially done. I'd like to thank our presenter again for a tremendous job. Thank you so much, Anh Ho.
Thank you for having me.
Everybody have a great day, and with this, we can all log out.
All right.